But this set, as a set, actually might have a supremum and an infimum. So, in fact, let's just go ahead and give those names. So, I'll let S superstar, get it? Superstar, be the supremum of V, and I'll let S substar be the infimum of V. Now notice, these always exist, because this is extended reals we're considering. It might be plus infinity or minus infinity, yes? Okay. Now, these actually have alternate names. So this is sometimes called the lim sup. Okay. And this is sometimes called the lim imp of the set E. Okay. Or sometimes you hear this term, upper limit. I think this is the term the book uses. Lower limit of E. Okay, these are all alternate names for these things. In modern parlance, this is often lim sup or lim imp are the terms we use. Okay. Sometimes you'll see lim sup and lim imp with symbols under them, although you don't need to put them here because we know what it means. But you might say, sorry, I shouldn't say SN. This is lim sup of SN and lim imp of SN, not E. E is just what's defined in terms of SN. Sometimes you'll see the n goes to infinity symbol there. You don't have to have that there because we have some sense of what this means already, but it just indicates the index that we're using. Okay. Here's an alternate way to think of lim sup and lim imp, and this is the one that I find most useful. I don't know that it's mentioned in your book, but it's certainly one that helps explain the notation. Why do you think it's called lim sup? And it's not because we're chopping off things and putting them in broth. Good. Oh, well, something like that. It's the limit of a certain set of suprema. And really what you're doing is you're looking at all the terms past a point. So look at all the k bigger than n, take their supremum, and then take the limit as n goes to infinity. So the net effect of this is it chops off all the initial behavior of the sequence. Okay? And you're only looking at sort of the long-term behavior. And that's why this concept actually arises, believe it or not. We'll see that when we talk about ratio tests. But here we go. This is similarly lim of an infimum of k bigger than n of s sub k. Now, I'm not going to prove this, but you can show that this actually is equivalent to the largest sequential limit and small subsequential limit definitions. Let me do some examples, and then we'll call it a day. So here's an example. Tell me what's got to be true about the lim sup and lim imp if the whole sequence converges. Yeah, if this whole sequence converges, guess what? The lim imp has to equal the lim sup. And they both have to be what? S. There's no other thing it could be. You're just chopping off the initial behavior, looking for the lowest subsequential limit and the upper subsequential limit. All subsequential limits have to be S if it converges. All right. Good. Let's look at a sequence where you don't have that happening. How about this one? How about 0.1, 3/2, 0.11, 4/3, 0.111, 5/4, 0.1111, 6/5, ... There's a sequence. Maybe I should put braces here to indicate it's a sequence. Can you see what its lim imp and lim sup are? On one hand, some of those 0.1s, these things are going up. And then there's the 3/2 and 4/3, which are going this way in some sense, like this, right? Can you see what the lim-inf and lim-sup are? I think the lim-sup is 1, and the lim-inf is 1/9. I have the wrong thing in my notes here, actually. Okay. Lim-inf and lim-sup. Okay. If I were to say that something was bigger than the lim-sup, what would that really mean? So here's the lim-sup. If I were to say that a number is bigger than the lim-sup, what is that? What's another way of saying that? It means that, does it mean that all the terms are necessarily bigger than x if x is bigger than the lim-sup? No. But it must mean what? Must mean what? Not all the terms are necessarily bigger than x, but can you say eventually all the terms are less than x? Yeah, eventually that has to be true if x is bigger than the lim-sup. There's a theorem in your book that makes that precise. But really, you can make similar kinds of arguments that we made before with limits, with lim-sups and lim-infs if you're just careful. Okay. Okay, that's good. Next time, we're going to start talking about series, which are special kinds of sequences.